Good afternoon, everyone. I want to welcome you to my lecture today. Of course, we are starting the last chapter of the semester, which I call chapter 10. Okay, we're starting today, and on Friday we actually going to finish that. So today, our focus is going to be 1-2 sample hypothesis testing of proportions. Okay, so we want to dedicate today to hypothesis testing of proportion and Friday to hypothesis testing of means. Okay. Now, in the introduction, I'm actually going to introduce you to hypothesis testing. So, what our intention is. Then I'm also going to walk you through the elements of hypothesis testing. Then I'm going to walk you through how we test hypothesis about proportion for one sample and for two sample. I'm going to back up that with illustrative examples. Okay, so let's get started. Okay, hypothesis testing. Let me tell you this. You know, um, we find ourselves in a world where um things are changing, just like what I used to say, we live in a probability space. And you know what? When scientists observe the nature, they normally come out with an hypothetical statement. Okay. And when they come out with an hypothetical statement, uh, to be able to see, to be able to show that, okay, what they observe is what really happened in reality, you know what they're going to do? They're going to go to the population and take a sample and test whether there is agreement between their observation and the sample data. Okay, so in this kind of world, we're always going to have certain thing in mind, you know, about the nature. And let me tell you this: our mind can never be empty. There's always going to be something occupying our mind. So that is what we call hypothesis. Hypothesis actually means an assertion, okay? An assertion, okay? It means an assertion, okay, about the value of a parameter, okay? Like an assertion or a conjecture about the value of a parameter. We find ourselves in a world where we always want to figure out the value of a parameter. I told you the other time. Parameter is a population characteristic value that we seek to determine. It could be mean, it could be proportion, it could be difference of proportion, it could be difference of means. We want to figure it out. So, but in figuring it out, we normally have an intelligent guess. When I say an assertion, I mean intelligent guess. Okay, intelligent guess. This guess, I call it intelligent guess. Is not all guesses that are intelligent. Does that make sense? Okay, so if I now want to ascertain the validity of an hypothesis, then I'm actually going to put it to test. So testing the validity of a claim is what we call hypothesis testing. Somebody have a claim, okay? And how valid is the claim? Because the person could have a claim and it could be wrong or right. So testing the authenticity of that particular claim now is what we call hypothesis testing. And I'm going to walk you through a motivating example right now. Okay? Take a look at this. A Diet company advertises that at least 75% of its customers lose 10 pounds or more within 2 weeks. I will call that an hypothetical statement because that statement has not been proved, okay, tested and confirmed. Okay, now whenever there's a claim, investigation follows a claim. We're gonna investigate. Now that was why you suspect the company of falsely advertising the benefit of taking their piece. Suppose you take a sample of 100 product users. That's an investigation. Whenever there's a claim, there's always that will be followed by an investigation. Okay, and find that only 5% have lost at least 10 pounds. Okay, the company claim at least 75%. If you now find out that at least only 5% lost at least 10 pounds, now is this enough to prove your claim? What about if 72% have lost at least 10 pounds? Now let me tell you this, because when we conduct this investigation, okay, we normally need to have a sampling distribution in mind, where we're going to have opportunity of conducting what I call a repeated experiment, because if different researchers should conduct this study, some people could actually discover 5% loss, even some could say 70% loss. Okay, the statistic becomes a random variable. You understand the other time that we look at the sampling distribution. Now, merely looking at a statement like this, okay, is not enough to take a decision. A standard statistical procedure need to be conducted before we're going to take a decision. Does that make sense? Okay, now, what is the goal here? Our goal is to use sample data to formally test hypotheses about unknown population parameter. We always going to test hypotheses about unknown population parameters, which could be mean or proportion. Does that make sense? And we really want, if you take a look at hypothesis formulation, it's actually centered around parameters. It does not center around sample. It centers around parameter, because it's an hypothetical statement. Okay, it's an intelligent guess about what the value of parameter is going to be. When I talk about proportion, maybe I really want to know what is the proportion of Americans that approve the job the president is doing. Or maybe I really want to figure out what is the true average, the annual average household income in a country. Or I really want to know, is there a statistical significant difference between the standard of living in two countries? Or can we say the infection rate upon vaccination using different or two different vaccine? Can we say the infection rate is the same or no? Stuff like that. Okay. And you know what? Like I said, our mic can never be empty. Now, for you to be able to understand hypothesis testing, we need to be able to understand some nomenclature, like some fundamentals of hypothesis testing. Number one is what we call assumptions. Okay. Now, let me tell you this. It's just like a court want to entertain a case. Okay. That very court must have a credibility. We should be able to rely on whatever decision coming from the court. And we're always going to have an assumption moving forward. Okay, the assumptions of the hypothesis, now the reliability of any hypothesis test rely on certain set of assumptions being satisfied. And we're actually going to be showing you those assumptions depending on what you are testing on. You remember when we're doing estimation, okay, when we're doing interval estimation the other time, we got time where we're going to use certain formula. We got time where we're not going to use it. You remember when Z score appears in our formula. Okay, the Z score appear because we are assuming sampling normality of a sampling distribution, or we're working with a large sample size, or the population variances are given, stuff like that. So we got assumptions, and I'm actually going to review that to you as time goes on. Okay, every hypothesis testing as assumption. Now, the next thing is to talk about hypothesis. Just like what happened in the court of law, when somebody is accused of wrongdoing, there exists two hypotheses before the court of law. The very first one is going to presume that the accused person is innocent, and the second one is going to presume that the accused person is guilty. Now, also in a scientific hypothesis, we got two forms of hypothesis. The first one is actually called null hypothesis, and the second one is called the alternative. The null hypothesis is symbolically represented as HO, alternative as HA, and the null hypothesis is actually going to give a statement about the population that we want to disprove. Okay, it represents hypothesis of no effect, no difference. Does that make sense? Why the alternative? Alternative, on the other hand, that is the hypothesis we actually hope to find evidence for. We want to find evidence for that, so that we'll be able to reject the non-hypothesis. Does that make sense? Okay. Now, and I said it should be stated before looking at the data, before we go into our data. Okay, it's just like before the court of law, before the evidence. Okay, those two hypotheses exist even before listening to witnesses and stuff like that. These two hypotheses, is guaranteed. That is where to start from. Does that make sense? Okay. Any question on that? Okay, now the whole thing is going to start from hypothesis formulation. Now, if I want to go back to the motivating example right here, in your question, you should be able to identify the hypothesized value. The hypothesized value we actually come in terms of a claim. Take a look at this guy here. Okay, this particular company actually claim that at least 75% of their customers. Now, this is going to be on our proportion. Okay, now 75% is going to be 0.75, right? If I want to specify that, this is the way I'm going to specify that. Statistically speaking, HO is going to be P equal 0.75 HA. Now, let me tell you in the actual sense. They say at least, right? The guy claim at least of the non-hypothesis is symbolically represented as HO, alternative as HA, and the non-hypothesis is actually going to give a statement about the population that we want to disprove. Okay, it represents hypothesis of no effect, no difference. Does that make sense? Why the alternative? Alternative, on the other hand, that is the hypothesis we actually hope to find evidence for. We want to find evidence for that, so that we'll be able to reject the non-hypothesis. Does that make sense? Okay. Now, and I said it should be stated before looking at the data, before we go into our data. Okay, it's just like before the court of law, before the evidence. Okay, those two hypotheses exist even before listening to, witnesses and stuff like that. These two hypotheses, is guaranteed. That is where to start from. Does that make sense? Okay, any question on that? Okay, now the whole thing is going to start from hypothesis formulation. Now, if I want to go back to the motivating example right here, in your question, you should be able to identify the hypothesized value. The hypothesized value we actually come in terms of a claim. Take a look at this guy here. Okay, this particular company actually claim that at least 75 percent of their customers. Now, this is going to be on our proportion. Okay, now 75% is going to be 0.75, right? If I want to specify that, this is the way I'm going to specify that. Statistically speaking, HO is going to be P equal 0.75 HA. Now, let me tell you in the actual sense. They say at least, right? The guy claim at least. At least supposed to be greater than or equal, right? Okay. And what is the opposite of greater than or equal? That's going to be less than, right? Okay. Now, this guy that guy supposed to be in the norm, but you know what? We normally like writing equality sign in a non-hypothesis. But based on this question right now, okay, it is greater or equal. But we normally like writing equality, okay? And if I know this guy for the no, the opposite or the complement of that would be the alternative. That was why you saw a less down. And let me also tell you this. I needed to pay attention now. Under the non-hypothesis, depending on the kind of textbook that you are using, there are three possible values. There are three possible signs the non-hypothesis can have: equality, less than or equal, greater than or equal. But let me tell you this, most of the time, we prefer working with equality, even though it is less or equal or greater or equal. And when it comes to alternative, there are three possible signs. Okay, not not equal, greater than sign, then less than sign. I need you to pay attention to this. You can never have less or equal to or greater or equal to in the alternative. It's not going to happen. These are three possible signs. And I told you for equality, for the non-hypothesis, we always use equality sign. But for the alternative, it could be any of these symbols, and that depends on the question. Is there any question before moving forward? Okay, if that is clear now, I'm actually going to move to the next one. The procedure for conducting hypothesis testing, number one is check for assumption. I've just showed you. Number two is formulation of hypothesis. I just showed you the specification of hypothesis. Specifying hypothesis like state your not hypothesis and state your alternative. The third one is going to be test statistic. The third one is a test statistic. That is where we're going to have a formula that we're actually going to use. Now, a test statistic is a measure of how compatible the data is with the non-hypothesis. Okay, don't forget, we are actually seeking for evidence in the data to be able to go against the non-hypothesis. If the evidence is actually sufficient, we're actually going to go against the non-hypothesis. If it is not, then we got no choice. We're going to fail to reject the non-hypothesis. And let me tell you, the larger the test statistic, then the less compatible the data is with the null hypothesis. When the test statistic is becoming larger, okay, that's a deviation away from the null. And when you have a deviation away from the null, that is actually moving us towards direction of the alternative. Does that make sense to everyone now? Now, this is mathematically speaking, this is the way it's going to be. So it's going to be estimator. Okay, estimator is a theta curve minus the hypothesized value, okay, divided by the standard error. Okay, divided by the standard error. Okay, I just wanted to take note of that. Now, what does an extreme value of t reflect? Okay, you know what we mean by when t is extreme. Okay, the sample estimate is many standard deviation away from the hypothesized value. Don't forget, if this guy is extreme, right? It's so many standard deviations away from the hypothesized value. And when it is so many standard deviation away from the hypothesized value, then it means the data don't agree with the hypothesized value. When the data don't agree with the hypothesized value, then we're actually going to reject the non-hypothesis. And that is exactly what we're looking for. We want that to happen, okay? Now, that is the test statistic. Then the next thing is, the next step is the p-value. Okay, what we mean by p-value? The p-value is the probability of observing an extreme value when the non-hypothesis is true. So what is the probability of observing an extreme value? Okay, the probability of observing extreme value when the non-hypothesis is true. Let me tell you, when p-value is small, we know if we want to take a statistical decision, we normally compare the p-value with the level of significance. There's always going to be level of significance, alpha. The level of significance is the level of statistical error. When p-value is less than the level of significance of the test, the non-hypothesis is rejected. But when p-value is greater, do you know what is going to make p-value to be small? When the test statistic is large, p-value will be very small. When the test statistic is small, p-value will be very large. If I want to reject the non-hypothesis, then I'm expecting p-value to be small compared to the level of significance. And how are we going to figure out the p-value? To be able to figure out the p-value, that depends on the nature of the alternative. I'm going to say that again. To compute the p-value, that depends on the nature of the alternative. Now, let's come to that example again. Suppose that in your sample, okay, of 100 customers, 65% had lost at least 10 pounds in 2 weeks. You know, the company claimed that within 2 weeks, at least 75%, okay, when you now conducted a sample of 100 customers that use their P's, it's only 65% of them that have actually lost 10 pounds. Now you put forward this hypothesis, okay? Now, after putting forward this hypothesis, then you now want to go, you want to see whether assumption hold. Okay, you know, I told you we need assumption to be able to know whether we're going to seek redress using the z-score. If I want to conduct this test, okay, is the sample size large? The sample size is 100 here. The sample size at least 30. It is greater than that. And not only that, we need to look at MP. Is MP greater or equal to 10? You remember? Is MP MP greater or equal to 10? Oh my God, what is happening here? So it's NP is NP greater or equal to 10 and N into 1 minus P also greater or equal to 10. What is your P? That is 0.75. If I multiply it by n, what is your n? 100, right? 100 times that is 75. Of course, that is greater than 10. Okay, then what is 1 minus P? 1 minus P will be 0.25. 0.25 times 100, that is 25. That is also greater than 10. Then when that happens, then I can assume a normality. Normality facilitates the use of z-score. Now, because of that, you know what I'm going to do? I'm actually going to say the sampling distribution of P is normal. Does that make sense? The condition under which it has to be normal is that NP must be greater or equal to 10, and N into 1 minus P must be greater or equal to 10. We call the first one number of successes, the second one numbers of failures. Does that make sense? Now, because of that, because a P cap, the P cap here is the sample proportion, okay, is a random variable. Okay, we want it to follow normal distribution, and the only way that is going to follow normal distribution is when these conditions of NP greater or equal to 10 and then it's 1 minus P greater or equal to 10 have to be met. Now, what am I trying to say now? What I'm trying to say here is that, okay, you know what, when that condition is met, normality of a sampling distribution is guaranteed. Now I'm going to say P cap now follow normal distribution with a mean of P0, and this as the standard error. Okay, and what is that? What is the P0? What was the value in the hypothesis? 0.75. And that is what you're also going to plug in here. What is your N? 100. And at the end of the day, you know what I got? Then I'm trying to tell the world the mean of the sampling distribution is 0.75. The standard error is 0.04. Is there any question on this? Is there any question on this? If there's no question, then I'm going to move right now. Now I'm going to use that formula. Then I'm just going to plug in. I want to get my test statistic now. Okay, what is my pickup? You know, what you get in your sample, you got that out of 100 users of this pill, 65% have lost weight. That would be your pickup. Okay, that would be 0.65. Then the P0 is actually the hypothesized value. And don't make a mistake. Please be focused. Whatever your P0 is what you're going to plug in the denominator. You know, in the past, I've seen some student plugging in this guy. That's going to be wrong. But do you know that when we're dealing with the confidence interval, what do we plug in inside the square root? It was a P cap. Do you remember? Let me remind you of the confidence interval that we did the other time. P cap, right? Plus or minus. Okay, Z alpha over 2. Okay, square root of P cap 1 minus P cap divided by N. Can you see the difference? In the confidence interval, the whole thing was P cap that you're putting inside. But in the hypothesis testing, don't put P cap. It's going to be the hypothesized value. Does that make sense now? Okay, if that makes sense now, our test statistic gave us negative 2.5. When we have a negative 2.5, this very T here is the same thing as Z. Okay, we got Z to be negative 2.5. What are we going to do next? Then we need a p-value associated with that. How am I going to get a p-value associated with that? This is what I'm actually going to do. I'm going to go back to the alternative hypothesis. Please, I need you to be focused. If I want to determine my p-value, then that depends on the sign that I have in the alternative. If the sign is less than, then my p-value will be the probability of Z less than. So it's going to be this guy. It's going to be this guy. Do you understand this guy now? If I want to get my p-value, there's going to be probability of z less than. Where is the less than coming from? It's coming from the alternative. If the alternative is greater than, this guy is going to be greater than. And you know when you have a greater than, right? Whatever you check from the table, you're going to subtract from 1, right? But this is a less than. If I check a negative 2.5 from a z table, automatically going to give me 0.0062. That is the p-value. Now, if this guy is a p-value right now, for me to be able to take a decision, I need to compare this guy with the level of significance. Now, I'm actually going to go back, to ask, do they specify level of significance? Okay, they did not specify the level of significance. Of course, in the exam, I'm actually going to specify the level of significance. Situation where level of significance is not specified, we use the standard level of significance that is 5%. Does that make sense? It's 0.05. I'm going to say that again. When the level of significance is not given, you're actually going to use a standard level of significance of a 0.05. Now I'm going to compare this guy with a 0.05. What happened? This guy is less than that. Okay, when a p-value is less than a given level of significance, then the null hypothesis will be rejected. Now, I'm going to go back now. Okay, I'm going to go back to the hypothesis. Okay, because the p-value of a 0.0062 is less than a standard level of significance of a 0.05, then we are rejecting the null hypothesis. Rejecting the null hypothesis means we have a sufficient evidence to reject the null hypothesis. And don't forget, the null hypothesis is the claim of this company. So rejecting that, and that was why we're actually having the decision here. And that was why I said, in general, the smaller, I told you, the smaller the p-value, the more the evidence we have. Okay. Now, the interpretation, I said, if the proportion of customer that lose is at least 10 pounds is truly 0.75, it is very unlikely that we will choose a sample with so few people achieving this weight loss. Okay. Our data provide evidence that H0 is false, because the p-value is less than 0.05 standard level of significance. Now, we're now going to have our conclusion now. We assume that H0 is true and put the burden of the proof on that. Therefore, we can use the p-value to decide whether or not to reject or not. Okay, so now we have already rejected. Is there any question on that? Go ahead. Okay. Oh, if you're going to use a software for this Z, you're always going to see T. But T and Z behave the same way when the sample size is large. Does that make sense? And how large is a large? It has to be at least story. So T and Z behave the same way when the sample size is large. Does that make sense? Okay. That's a very good question. Okay, now I want to move right now. Okay, I want to move right now. Now, this is the decision, the idea surrounding the decision. When p-value is less than alpha, you reject. When p-value is greater, then we fail to reject. Rejecting a null hypothesis means we have found sufficient evidence to do so. Failing to reject, let me tell you this. I'm going to tell you something now. In the court of law, when the court found that the accused person, maybe they reject the non-hypothesis, maybe the non-hypothesis is that it's innocent, right? And the alternative is that it's guilty. If they have found a sufficient evidence that is guilty, there is possibility that he did not commit the offense by nature. Does that make sense? And that is the reason why the court is always going to say, wait, the evidence before these courts. Does that make sense? It's time coming, I'm still going to discuss with you possible errors in hypothesis testing as well. Also, they can make errors in research as well. Okay, now that is it. Now I gave something here. When alpha is 0.01, you know what I mean? When the level of significance is 1%, it means you are 99% confidence. If it is 0.0155%, it means you are 95% confident. If it is 0.10, then 90%. I just wanted to take note of that. Okay, now I want to present to you. I use. Don't let me make a mistake. I don't want to confuse you because when you are conducting a hypothesis about proportion, or you are constructing a confidence interval about proportion, I want us to use one when it comes to our assumptions. Okay, I just want you to stick to one. Okay, even though there's an argument, this and this, we use it for proportion when you are constructing confidence interval. For this class, when it is hypothesis testing, consider greater or equal to 15. Does that make sense? This is for confidence. For the hypothesis, okay, n p greater or equal to 15. N into 1 minus p greater or equal. So one is for the confidence, the other one is for the hypothesis. I want us to use that to, that's what I wanted to use for this class. And that was why you see this guy here. You see that guy? When you want to test hypothesis about proportion, okay, the condition should be that. But if you want to construct a confidence interval, it should be greater or equal to 10, Okay, now I just want to revise with you right now. When you are testing hypothesis about proportion, it could be that you are testing that against less than, or you are testing that against greater than, or you are testing that not against not equal. It could be any of that. You can see in every one of these, the non-hypothesis has a quality sign, then the alternative has a sign that is changing. Now, whether you want to conduct any of those tests, okay, you're actually going to use the same test statistic value, but provided assumption hold. Does that make sense? Provided assumption hold. Now, can we also, if I have this kind of test, how do I figure out my p-value? I told you the other time, p-value depends on the nature of the alternative. How do I figure out my p-value here? How do I figure out my p-value here? How do I figure out my p-value here? Okay, I'm going to show you how you figure out your p-value now. Can you see that? For the hypothesis 1, your p-value will be z less than, because the alternative is less than. For the hypothesis 2, your p-value will be z greater than. And when you check a table, whatever you check from table, you have to subtract from 1 for the greater than sign. Then how do I test hypothesis for two-tail? For two-tail, how do I get the p-value? The p-value is going to be 2 multiplied by the probability of z greater than the absolute value. When your test statistic is negative or positive, we actually want it to be positive. Does that make sense? So if you take a look at the hypothesis 3 now, where your alternative hypothesis is not equality, you need to fall or force like uh, convert negative test statistic value to positive, false, taking the absolute value, then go to the table, check the normal table, subtract from 1. After subtracting from 1, then multiply by 2. Okay? Now, this is just to show you the corresponding curve. Take a look at this side. That's to be left, right? If you take a look at this guy, that's to the left. If you take a look at this guy, that's to the right. If you take a look at the other one, double-sided. Does that make sense? We're just trying to show you the picture for them. Okay, now what is the decision? In any of those tests, decision remain the same. We are uniform in decision. When p-value is less than alpha, okay, alpha is always going to be given. If it is not given, you use a standard alpha level, 0.05. Does that make sense to you now, right? So this is the condition. But let me tell you this. We don't say, let's say, for instance, the p-value is greater or equal to alpha. We don't say we accept. We normally say we fail to reject. Somebody's going to say, what is the difference? When I fail to reject, it means I'm accepting. We don't use that in statistics. We're actually going to say we fail to reject. It's either we reject or we fail to reject. We shouldn't mention we are accepting. Does that make sense? Okay. Now I'm going to go into another example now. Okay. And this example has to do with a greater than. How do I know it's a greater than? The manufacturer of a new breast cancer screening method claims that it detects cancer in more than 83%. Do you see that? More than. Okay. You have to pay attention to the question to be able to see what the direction. More than 83%. If I'm specifying now my hypothesis, that's what I'm going to have. Now, it detects cancer in more than 83% of women who have it. To investigate, they apply their screening method to a sample of 203 randomly selected women to have breast cancer, and the test detects in 184 of these women. Use this information to test the claim at a 0.01 level. Here now, they've given you the level of significance. Now, I'm going to start. The procedure is to start with assumptions. Assumption we're starting here is more or less look like in a court of law. Before a court can entertain a case, that very court must show the world that they have what they call territorial jurisdiction. Has anybody heard about territorial jurisdiction in law? You know what they call territorial jurisdiction? If somebody that will be tried in this court, okay, then where the person commit the offense should be in the territorial jurisdiction of the court. So when somebody commits an offense in the state of California and the person run to the Minnesota, if Minnesota court should try the case and they were able to establish the fact that a commit the offense, whatever their decision is will be declared null and void because Minnesota does not have a territorial jurisdiction for the case, okay, which means the guy didn't break Minnesota law. Okay, now what are you going to do here? Okay, here we're doing MP. What is N? N is 203, P is that gives us 168. That is greater than 15 required. Then we're also going to do it to the expected failure. That is 35, greater than 15 required. I told you for hypothesis testing, that is your point, your point place of call. Okay, now after that is satisfied, then I'm going to go to hypothesis formulation. Okay, you got to make sure you formulate the hypothesis correctly. Then after that, you move to the test statistic where you're just going to plug in your values, the one for p-cap, the one for the hypothesis. At the end of the day, I got a 0.88. I got 2.88. Now I need a p-value. If I want to get a p-value, it's going to be probability of a z greater than. Why greater than? Because the nature of the alternative is greater than. So if you specify the alternative wrongly, your p-value will be wrong. Okay? Now, and at the end of the day, we got the 0.02 as p-value. Then you compare this p-value now with the level of significance given. They gave you a level of significance of 0.01. So what happened now? This p-value is less than that. And when it is less, then you're actually going to reject. And that was why I said this. Take a look at my conclusion now. After the p-value conclusion, look at the procedure: assumptions, hypothesis formulation, test statistic. After test statistic, p-value. After p-value, conclusion. When you see this in exam, that you should follow that procedure: assumption to hypothesis formulation to test statistic to p-value to conclusion. Now take a look at the conclusion now. Because the p-value is less than 0.01, the H naught will be rejected at that 0.01 level. Now we have enough evidence to conclude that the true proportion of breast cancer detected by the new screening method is significantly greater than 83%. So which means that particular equipment is doing a great job. Is there any question on this? Okay, now I want to move right now. Oh my God, we've considered just one population before. We now want to consider two populations. But based on that, we're going to talk about difference of proportion. Take a look at this. We also, we may want to test hypothesis comparing proportions. We're also going to have assumptions. But let me tell you this. Assumption for proportion for one population is different from two population. Two population, they have to be at least 5. This product have to be at least 5. Does that make sense? Okay. Now, the hypothesis can be this guy, or this guy, or this guy. You see, it's an extension. Okay. Now, then what is the test statistic? The test statistic is going to be this guy, which is going to be p cap 1 minus p cap 2. Why is this guy 0? Because under the null hypothesis, the two are equal. If they are equal, they are different, is 0. Okay? And this is the standard error. Now, that is going to follow normal distribution. Okay? Now, what is going to be the p-value? The same thing that we've been doing. If it is less than, it's going to be that one. If it is greater than, it's going to be that one. It's going to be the same or true. Whether for one population or two population, it's also going to be the same conclusion. Does that make sense? Now, I will quickly go over this now. Okay, Survey USA polled 500 Americans and asked if marijuana should be legalized for medicinal purposes. The result of this survey are summarized in the contingency table. Okay, use this information to test at the 0.05 level whether younger people are more likely than older people to think marijuana should be legalized for medicinal purposes. Now, we are comparing two groups of people, younger and older. Now, the younger, of course, you see less than 50 years, right? That would be less than, that would be younger. Then greater than 50 years, that would be older, right? Now, what are we going to do? So if you take a look at this, 202, the characteristics of interest is legalized. So what is the totality? So that was going to be that divided by that, and this divided by that. And that is what you see here. Now, what you see here is the sample proportions for the two different groups. Then after having the sample proportion, oh my God, you can go to test statistic now, but you need to formulate your hypothesis, okay, younger, greater than older. Take a look at that. Then your test statistic, you plug in, okay? When you plug in, okay, if this guy is wrong, what you're going to plug in is also going to be wrong. At the end of the day, you find the probability of the Z greater than, that gives you 0.2451. Okay, the 0.2451 is greater than the level of significance. Now, what is going to be the conclusion? Take a look at my conclusion. Because the p-value is greater than 0.05, we fail to reject H naught at 0.05. We do not have when you fail to reject. Okay, when accused person If the court declared that the accused person is not guilty, that doesn't mean it's not guilty by nature. Because nature knows the truth. We are just trying to say, based on the evidence that we have. So we fail to reject H naught at a 0.05 level. Then you're going to say we do not have enough evidence to conclude at a 0.05 level that the youngsters are more likely than oldsters to support the legalization of marijuana. Is there any question? You can see the benefit of statistics in the real world. Because in the real world, different people with different ideologies, how do we test the validity of a claim? It could be a claim from politicians, it could be a claim from industries, it could be a claim from individual. How are we going to test the validity of a claim? And that is why hypothesis testing provide us with that opportunity to be able to do that. This is where I'm going to stop today. Of course, the hypothesis testing tomorrow will center on means. Today we centers on proportion for 1 and 2 populations. Okay, make sure you all stay safe and have a lovely day. Bye for now, everyone. See you on Friday.